Alright, welcome to 3.6, applications of linear equations. Finally, something where you're like, I get it, why do I care? Like, why do I need to do all this? Because we can get some real life experience now, people. One of my favorite sections. Okay, so, average rate of change. Remember we kind of talked about that being the same thing as slope. If we hadn't, and my apologies, I've failed you as a teacher. This is the same thing as slope. But that's something I have to know, right? Something I have to know. Maybe I didn't know that, right? Let's pretend I didn't. Let's pretend that's just some words. Okay. 1.1. The graph below shows the average number of towns spent watching, average number of hours per year spent watching TV for each person in the United States during the year 2000. I'm looking at the graph now and I'm thinking that's a typo, to 2004. Find the average rate of change in number of hours per year. Okay. Step 1, translate. This is going to be your motto for like the whole class. Translate, solve, translate back. Woohoo! Okay, so we need to translate this bad boy. What the crap do they want from me? Huh. Heh. Okay, well, a good place to start is probably the question, right? Or something like find, right? Now, this is a suggestion. There is no step-by-step for solving word problems. That's what makes them hard, and that's what makes them messy, and that what makes it really, really satisfying when you finally figure the I can't say the word I want to say, but figure the horrible thing out, right? So, what do we need? We need to find the average rate of change. That sounds familiar. Rate of change. The rate at which things are changing. Oh, slope. Okay, they want me to find the slope. That's a key aspect right there. If I didn't remember what rate of change was, if I couldn't figure it out, then I can't do this problem. So that's a big part of Translate. I kind of have to remember the vocab words. I have to remember the terminology. If I'm not in this chapter, I definitely have to remember what rate of change means, right? I can't be like, hey, Google, what is rate of change? It'll give me a bunch of rate of change, like definitions, and not one of them is going to say slope, I guarantee you. They'll be like, what is the rate of change in math class? No, I have to remember that. I have to be smart on the computer. Okay, they want the slope. Got it. I can find the slope. That's all I need to do is translate. I remember slope. Slope was that formula thing. y2 minus y1 over x2 minus x1. Or maybe I didn't like it that way. Maybe I like to use the table. So let's go ahead and use the table. Here's an endpoint to 2004. Here's an endpoint to 2000. I think, yep, they got off a little bit. That's weird. That's okay. It's fine. We'll go with those. Let's see. So that would be 900, and that would be 750. So 900 to 750, 150. Yeah, no. Yeah, 150. And then a span of, what, 4 years? And so our slope is 150 over 4. Great, that's math class, right? But now I have to translate back. Translating back would mean 150 over 4 number of hours per year. That's kind of awkward, right? So maybe we do actually want to take this to a decimal. 37.5. I'm going to double check that number. I'm pretty sure. 150 divided by 4. Yeah, 37.5. That's what we really mean. We mean 37.5 per year, right? 37.5 hours per year. The reason I care is because I actually have to speak English at the end of the day. If I say, oh yes, well, the average American spends his time 150 divided by 4 hours per year, you're like, bro, what's wrong with you? 37.5 is how we talk. So that's part of the translate back. Translate back is pretty important. You want to actually sound like a, competent adult. So, sounds good there. If I had gone the non-visual route, I would have had the same numbers, 900 minus 750. Over the same 2004 minus 2000. So we just kind of did that part in our head, right? But we ended up with the same numbers. If you're more of a visual person like myself and you prefer to have it actually written on the page, then you can do that. Totally fine. But either way, we ended up with the same 37.5 hours per year. All right, that's a lot of hours. Jeez, it's like over a day of watching TV. Although, now that I think about it, that number may have gone up. Okay, let's do another one. With all of these, I highly recommend you pause before each one and just try them on your own. There probably really shouldn't even be a video for this one, to be honest. You should just be doing them and practicing and translating as many as you possibly can so that you get good at that from the beginning. Anyway, I'm not mean though, so I'll keep a video. During the year 2000, the average person in the United States spent 866 hours watching broadcast TV. In 2004, the average number of persons spent watching TV was 678. Find the average rate of change in 2004. Okay, this is basically the same problem. This was one of those classes, or one of the ones where in class I was like, hey, now try it on your own. But, yeah, this one's not too bad. Doesn't give us a graph, though, so we're going to have to use information. 2000 was 866, and 2004 was 678. This is another way to organize your thoughts. This is not an underlining scenario. This is a pulling out tidbits of information and writing them down. Again, it's totally up to you what you want to do to organize this. There's no standard way of doing it. If you have nothing, then try one of mine. Try one you see and see if you like it that way. You want to underline stuff? Great. You want to do tidbits? Great. You want to find some other way? You want to use table? You want to use graph? You want to use, origami? I don't care. Do whatever you want. But try one out until finally it makes sense to you. Okay. Alright, cool. Rate of change. I guess I could do rise over run here, but I think just the formula, which is rise over run, might be pretty easy. I am going to fix that too if it is the end of me. Ugh. It doesn't like to draw the top half. There we go. Oh my gosh. Okay, it's fine. Alright, let's plug this in now. 866 minus 678 over 2004 to 2000. Okay, what'd I do wrong? Take a look at it for a sec. Now, obviously, I'm not saying I can't write, because we know that's true. But what did I do wrong? I did not coordinate my points here. Okay, my x2 on the top. Oh my heck, I'm sorry. This is bugging the heck out of me. Okay, 678. Okay, there we go. I didn't coordinate my points. If this was truly x2 or y2 minus y1 or x2 minus x1, well then we said 866 occurred in 2004. And that is not the case. Okay, I've messed this up. But this is something I see time and time again because people want to subtract bigger numbers from smaller numbers. However, 2000 minus 2004. And you can go backwards like that. That's totally fine. You can do x1 or y1 minus y2 over x1 minus x2 as long as you've flipped them both. Okay, and then the negatives work out. If that's going to overcomplicate things for you, then always start with the second one. Right? Just always start with the second one. In this case, we get a negative 4 on the bottom. 866 minus 678 is 188. Divided by 4 is a negative 47. So negative 47 is our answer. Negative 47 is our solution, maybe. It's our mathematical, mathematical option. Not option. Our mathematical arriving. That's what we got, right? But our answer, negative 47, doesn't make sense. Negative 47... what's hours per year. Even that doesn't really make sense. You can't have negative hours. So what does this mean? It doesn't mean negative 47. What it means is 47 hours less each year. Or you could say decreasing 47 hours each year. Or you could say it's going down by 47 hours each year. But you have to put it in English context. It makes no sense to write negative 47 hours per year. Okay, now there are some things that are negative, right? Velocity is often represented in negative. Losing dollars, your bank account, if you've ever had the unfortunate situation of owing the bank money because something got overdrawn or something, you have a negative 45 in there or something. And so some cases that is applicable, but in this one, That doesn't make sense. So we have to reword this problem so that it will fit the context of our situation. Okay, moving right along. This next one I love because you've all done it. You have all gone to the gas station and you didn't know it, but you were writing an equation. So we're just going to jump right in. Suppose it's time to fill up your car with gasoline. At your local station, it costs $3.20 a gallon for 89 octane gas. 89 octane gas is the gas that you see. It's unleaded. They call it unleaded now. Write an equation to represent the y cost for the gallons of X gas. Okay, and you may be thinking, no, Miss Kay, I have never once gone to a gas station and made an equation to represent the cost of gas. I will give you that you probably haven't used X and Y. But you definitely made an equation in your head. You definitely 100% made an equation in your head. I'm going to add a little bit context here just to prove to you. Have you ever had cash on you or your parents gave you a certain amount that you could spend on gas and you rolled up to the gas station and you had to figure out how much you could actually get in your tank? Guess what? You did an equation. Okay? If you sat there and said, okay, I have 20 bucks. How many gallons can I get? Well, what do I need to do? I need to divide 20 by 3.2 or $3.20 and see how many gallons that is. How do you know to divide? How do you know to divide $20 by $3.2? Because you just made the equation that y is 3.2 times x. You wouldn't be dividing if it wasn't times. You already made the equation. You were already solving the equation. And that's what I love about this problem is it proves to you that you've done math your entire life, but you just didn't know you were doing it because you're just that smart. Your brain is just too smart for yourself. Okay, so this would be our equation, right? Everybody knows that if I have, $3.2 for gas or for cost, and then I go buy a gallon of gas, it's going to cost me $3.20 because I'm timesing by 1. So we just do that with x and y, we get the same equation. Okay, moving right along. Now you suppose you can get a car wash for $3, which is awesome, for filling up at the gas station. How does that change your cost equation? Again, you've done this too. Let's pretend you have $20. You have a 10-gallon tank. Do you have enough now to fill up your gas tank and have this station? Well, what do? You say, okay, if I get one of them, or if I get 5 gallons or something, that's going to be this much, and then the $3 on top of that is that 20. The $3 on top of that, you're adding that to your cost equation. Oops. You're doing it already. If you already figured out that you have enough for 6 gallons of gas, but that's $17, oh, and you're like, yes, I can squeak by and get a car wash. Because you know that you have to add 3 to that, right? If you're like, oh, it's 8, and you figured out you have already paid $19 or whatever it is, then you're like, crap, I can't do it. I don't have enough. Because you know that you have to add 3 to that. You've done this already. You just didn't do it with X and Y. All right, cool. Oh, crap. All right, this one got squished in there without a space, so just right to the side. Now interpret the ordered pairs, 519 and 1035, in relation to your equation. Okay, we've already done that. We tend to think in the numbers first. So what does 519 mean? 519 means 5 gallons is going to cost $19. 5 gallons is X, right? So X was gallons, so X is now 5. If I plug that into my fun equation there, I get 19. Do you have enough for 20? Yes, I do have enough for my 20. If I plug in 10, I get 35. If I had 10 gallons, that's going to cost me $35. I don't have enough with my 20. Okay, I don't even have enough to get 10 gallons without the car wash. So, and again, that was added on. I added that on. But that's what this means in context of the situation. And arguably, it's more important than just an ordered pair. All right, cool. Next one. Also something that's pretty applicable. I don't know if you guys are thinking about this yet. You definitely probably should start. But average annual tuition costs and fees for in-state students at a public four-year college are shown in the table for selected years and graphed in ordered pairs in the scatter diagram below. Where x equals 0 represents 2006, and x equals 4 represents 2010, and so on, and y is the cost in dollars. There's a reason I'm underlining this right now because I want to bring your attention to it. Graphing, when it comes to years especially, is annoying. So the couple of the graphs we've had that have actual years on them, it's been hard to like gauge which line was which, and the lines always skew and things like that. So what a lot of people will do is choose a start year and call that 0, and then go from there, right? So like x equals 0 here on the graph does not mean we are starting in year 0 with Jesus, right? Chances are Jesus did not go to BYU. But that's a joke. Anyway, so here it's 0 represents 2006. And 2006 is where we're starting this information, and then we're progressing from there. And this happens a lot. So watch out for it. Okay, it's going to change your answers if you don't think about it. Something else, I know your probably eyes are bugging out from these numbers over here. This is accurate data. I don't mean to panic you. I also don't mean to like horribly disappoint you. It's true. College, you've heard by now, has gone publicly off the rails. I don't want that to discourage you from college, though. Okay, college is so much more than classes. If you thought about how much other stuff you do in high school, besides just go to class, times that by 10, because you're now living on your own, you're now paying rent, you now have a job, you now have experience, you have, college friends that are going to go with you for the rest of your life. And if you've chosen not to go to college, I'm not saying you can't have these things, but I don't want you to change your mind on college simply because of the cost. Okay, there are millions of ways to go to college and not have to pay out the nose for it, okay? There are hundreds of thousands of scholarships, not just Regents, first off. There are millions of more scholarships, and all you really have to do is, like, write a paper, or just, be African American or something like that. There's grants. You should look up grants. That's literally free money the government has decided people needed, but very few people actually take up on. And if you want to know more information about any of this, you should contact your counselors. But don't ever let the cost of college defer you from going, okay? Because it's so worth it. If there are other reasons, that's fine. But if it's just the cost, there are so many ways around that. And even if you do have to pay student loans, I'll let you know. I have about $45,000 in student loans right now after 6 years in school and including my master's. And honestly, I pay $100 a month. Like, they are not they are not crippling debt. Now, am I going to pay that forever? Yeah, but there's also programs to get those written. There's tons of options is my point here, okay? So please don't ever let the cost of college be a deterrent from not going. Okay, you need to go. Like, if you want to go to college, you should go to college. Don't ever let the cost be... No. Okay, good. Let's look at this. So find an equation that models data, again, spiel, sorry, and then use it to approximate the cost of tuition and fees in a 4-year public college in 2028. Okay, so any delayed people here, you may figure out how much you're going for 1 year in 2028. Okay, find an equation. Well, an equation, Well, if I look at the graph, this looks pretty linear. It's not perfect because it's the real world, but it looks pretty linear. So I'm going to try and make it a linear equation. That way, so now I need a slope, right? I'm going to take probably the whole span of data to find my slope. Since it's not perfect, I probably want to find like the first and the last one. So I'm going to take 2006, which was 2350, and then 2016 was 42,730. And I'm going to use these to find my slope, right? We did a problem where, like, here's 2 points, find the slope and find the equation. This is kind of why, because real life isn't going to give you a slope. It's going to give you a bunch of data. You got to go find the slope. So let's go find the slope. We could do this rise over run, but we still have to count it out anyway. So let's do the formula, 2016 to 2006. This is just maths. 42,730 minus 23, oops. All right, and then divide that by the 10, it's 2,000 a year. Okay. 22, what was it, 83? No, okay. It was an 8, wasn't it? I can't remember. 2730. 42,730 minus 2035 divided by 10. Oh, This is why I kind of don't like the calculator on the iPhone. It's because it doesn't have a remembering option. You would think that the calculator on the iPhone would have a remembering option. 38. Okay, so there's our slope. And so our equation, 2238 x plus our first value we're calling 2006 year 0. So there's my y-intercept. Sweet. Now I'm going to figure out 2028. So we'll go ahead and plug that in. I've kind of run out of room, so we'll go up here. So 2238 is 2028 plus 2350. Okay, let's go do that one now. 2238 times 218. $4.5 million? What? That sounds crazy. $4.5 million? That doesn't sound right. It's only been a couple years since 2006. Oh, wait a minute. That would be assuming this was starting year 0. I have to adjust for that, right? Because 0 is 2006. So 2028 is not what I should have plugged in. Notice how my answer got crazy big, right? So we don't want to do that. What should I actually plug in? How many years 2028 is from 2006, which would be 12. Right? 28 minus 6. Wait, no, that would be 22, right? Just kidding. 22 years. Yeah. Because 8 minus 6 is 2. Yeah. So let's try that one now. See if maybe that's a little more in the ballpark. Yes. While that still sucks, that makes a lot more sense, right? 70,000-ish is sort of what the numbers we're getting. Okay. 69, 850. Was it 850? You can't answer me. 856. 586 is what it was. Really? Oh, for the love. I much prefer my iPad. Just fun facts. Okay. 586. Okay. All right. That's how much it's going to cost me. Got to throw a $sign on that. And we're good. Okay. So, last problem before we get started. Try it out on your own. See how it goes. All right. Oh, this one got split. Sorry. Hopefully yours isn't split. Hopefully I fixed that before we get started. Or before I photocopy it. Retail spending in billions of dollars on prescription drugs in the United States is shown below. Write an equation that models the data and use it to predict the drug spending in 2007. Okay, so like we just did this problem, so let's do it again. I'll go ahead and do slopies. I'm going to go real fast on this one because we, like I said, literally just did this problem. That would be 2004, it's 221. And 1999 is 126. Okay. So now I'll do a slope. 221 minus 126 over 2004 minus 1999. 95 over 5 years. 19, yeah, 19 years. Okay, so 19 is my slope. So I will write an equation. Y equals 19x plus, starting in 1999, was 126. Okay? Now, if you still have no idea how I did that, and that is not fluent to you yet in section 6 of this, please come see me. Please come see me so I can help you make an equation. Okay, it's probably just a couple things, right? You drop something here and there. I will gladly help you. Okay, so now I need to predict 2007. Now I don't want to fall for that same trap I did with the 4.5 million. I want to make sure I do this right. So if this is starting in 1999, how many years till 2007? That would be 8. 8 years. Okay, I'll plug that in. 19 times 8 plus 126. 278. Well, first I'm going to box this guy. $278, right? For the entire United States? Sounds wrong. Why does that sound wrong? Nothing to do with the math. Has to do with the translate back. Can't drop little things like in billions. $278 billion in 2007. And if I hadn't gone back and said in the United States, we probably wouldn't have even thought about it because our graph is that way. Our graph is in 3-digit numbers. Our slope was in a 2-digit number, right? These were all small, but I didn't think about the context of the problem. So you have to make sure you always do the translate back step. You can't just slap on a units. That's not what I mean. I mean you think about it and you sound reasonable. You sound logical, right? You sound like a competent adult. Because that's what you are now. Okay, arguably one of the best sections because we have to do so much thinking, but that's a good thing. Brain is a good thing. You want to use thinking. Okay. Let me know if you have any questions. Shoot me an email. Other than that, have a great day.